Hello, my name is François Gazzano. Today, I present you an overview of the latest load management and injury prevention research, share some experience that I accumulate over the years, and explain how to implement a quality athlete monitoring and workload management program in a simple and practical way. So here is how the webinar will unfold. First, we'll go over a few injury statistics, the causes and risk factors. Then we'll go through a couple of important concepts and definitions, discuss the monitoring tools, and then go over the key evidence-based load management metrics. Finally, we'll put everything into practice during a quick tour of athlete monitoring, and then we will conclude with a few recommendations to help implementing a workload management system easily. After the formal presentation, we'll have about 10 minutes for a question period. So sports injury are a big problem, and this is happening at all levels. For example, here, those are recent statistics about high school and college athletes. We have in the US, there is more than 1.5 million of high school and college athletes who get injured every year. In the UK, sports emergence about 300,000 per year. In professional football, professional soccer, 30% of them are experiencing mental health issues compared to 13% in general population. So injuries are not just physical, muscle and joints and ligaments. They are also severe mental health issues as well. 60% of the professional football players do one severe or muscle injury. Injuries are not bad luck. Very often we hear, well, the athlete, that's bad luck. We didn't anticipate that. That's very unfortunate. Well, in many cases, this is not bad luck. This can be actually prevented. There are a few studies here that explain how it can be prevented. Well, or at least how the injury are occurring. Players' rating of fatigue and sleep quality are significant predictor of injuries, study for 2015. Fatigue contributes directly to ACL injuries. Football players, this is American football players, university players, are 3.920 times more likely to get injured when there is a high academic stress during exam period. In concussion, in professional ice hockey, average playing time is a significant predictor of concussion. And here, that's related more on long-term training load. An unusual increase in training load is also a predictor of injury. That's a study for 2013. Fatigue is a key factor. The reason is that it decreases the decision-making ability, decrease the coordination, decrease the neuromuscular control, and of course, you increase the risk. Decision-making, coordination, concussion. Decision-making. You cannot see the opponent is going faster, what I'm doing, boom, you get hit. Then you can coordination. You're making technical mistake. Neuromuscular control. You're landing on jump and then your knee is giving up. The problem is fairly simple. Fatigue is one of the main culprits here. And the problem is fairly simple because when load is the capacity of the athletes, then injury often occurs. On this graph here, we see that's the base level. Here we apply the load, which is like a game or training session. And then that's a recovery period. So that's the peak level of fatigue when athletes is basically because of the session. And if we leave the athlete recovering, then it will be bouncing back and then develop some adaptation to make it a little bit faster and stronger and more resistant. But if we apply another load here, when the athlete didn't recover properly, then the level of recovery will be lower and lower and lower. And then the ability of accept load increase susceptibility to injury. So this is a maladaptation that when load is not applied properly. So there are two main situations when loads exceed the capacity of the athlete. The first one is when athletes are psychologically and physically unfit to tolerate the prescribed load. So for example, when you have athletes who are training at a lower level and then they are going with the first team and then the playing speed is much faster and so on. So they are not ready. And if they are staying too long on the game, then they will likely to be extremely tired within the match, and their problem can occur. And another situation that is very frequent when athletes are very fit and well trained, but they need a rest. So there is an example here with Lara Gut. She's the defending world skip champion. She's a Swiss woman, and she torn an ACL ligament earlier this year. And in an interview here, she said in French, "There is no bad luck in the injury." Well, and in the interview that I translated here, rhythm was frenetic. Time was flying too fast. I never had a minute to relax for myself. I asked for a break for months. So this has nothing to do with fitness and ski performance. They are just the athletes need a rest, need a break. She didn't do it, then she went skiing and then she got injured. The risk comes from many sources: training competition load, training schedule, competition schedule, all the factors, inadequate warm-up. There is, particularly in soccer, there is the FIFA 11 program that is a warm-up protocol. that is extremely effective in preventing injuries. So this is to eliminate inadequate warm-up issues. Then this kind of protocol can be used. For fitness, when athletes are not very properly fit, and then they have to do some, for example, after the summer break, they go to the training camp, and then some of them are very fit, well trained, but some didn't work out during the summer. So they are coming to the training camp, and then they have to do some drills and some activities. And then because they are poor fitness, they get injured, or they get fatigued earlier, and so then they get injured. So the key is to focus on factors you can control. Some factor you cannot control, like the type of sport. So some sports are more dangerous than others. Early sport specialization, if the kids are training specializing too early, then they are more prone to overuse injury. For health, those kind of elements here can be addressed through education, level of stress, post-sleep quality, and so on. The age is another factor you cannot really control. Workload management is key. The goal is to reduce the risk and improve the performance. So that's very simple. And how to do that? Well, by monitoring fatigue, sport and non-sport physiological and psychological stressors. That's the first element. The second element is by detecting inadequate workload when training load is too low or too high based on the capacity of the athlete. And then adapting the training program, recovery and rest based on individual response, fatigue, wellness, fitness, and so on. So this graph here is a combination of different studies and just to illustrate the relationship between training load, the gray line here, that's the performance. So typically the higher the load, the more the performance until a certain point. That's the top performance. And if you continue to increase the load, then the athlete will go into overreaching and then overtraining if you go even further. Those are injuries in red, and we'll come to that a little bit further down in the presentation. But here, if we have low training load, you have a injury rate is high training load, risk of injury is high. But here there is a place where training load is high and injury risk is low. And this is very interesting because this plays a key role in load management. And those AC ratio, those are the acute chronic workload ratio zone identified by Tim Gabbett. So this graph summarizes the relationship between the performance, the injury, and the load, and where the athlete try to get each individual athlete. We should try to get the athlete into this particular zone. What's load now? So we talk a lot about load. We hear about load everywhere. When I started monitoring training with the first athlete monitoring system back in early 2000, a handful of people around the world were mentioning load, training load, and so on. Now it's everywhere. So which is good hopefully for the athlete, and hopefully more and more athletes will benefit from that. So the definitions, I think it's important to clarify the terms. So the first, you have load or workload. Those are kind of synonymous. Workload is the word coined by Tim Gabbett. That's the word he's using. But also we can use load. So those are two synonyms. So that's a combination of sports and non-sports stressors. So the tool to analyze that, to monitor them, you have questionnaire, you have session RPE, you have some wearable devices. So it's a combination of different things. You need to use different tools to monitor the total load. Then you have the external load. External load is basically the work that the athlete is doing, the objective work, the thing you can measure. So it's the external stimulus applied to the athlete. The distance, the weight, the number of sprints, the number of high-speed running, that kind of thing, the weight lifted. So the tool to measure external load is you have accelerometer, GPS devices, dynamometers, and so on. And then you have internal load. Internal load is the response, the psychological and physiological response to the external load. So the effect of the external load combined to non-sport stressors is the internal load. So internal load is physiological and also psychological. To monitor the physiological component, you can use heart rate monitors, lactate in specific situation because this doesn't work for everything. And to monitor both elements, you can use the session RPE. Internal load is a trigger of training-induced adaptation. So internal load is the response to the work from the athlete, and it's really very, very important to monitor internal load, and based on the response of internal load and a couple of other elements, then you adjust the external load to the capacity of the athlete. Measuring internal load. The first, we'll start with heart rate. So the rationale, so many heart rate monitors are now on the market. This started back in the 80s when there was a lot of research done on physiological parameters, VO2 max, and so on. And then now more and more those heart rate monitors are used in team sport and athletic training. There is a linear relationship between heart rate and the rate of maximum VO2 or oxygen consumption. So that's basically those lines here. The blue line is the heart rate, and the green line is the consumption of the oxygen consumption. So you can see those two lines are fairly the same, fairly parallel. So based on that, then you can identify, well, based on my heart rate, percent of my heart rate, I will be at that level of my VO2 max. This is basically what we have here, heart rate curve, heart rate monitor. And then you can divide that in based on your individual maximum heart rate and resting heart rate. You can have different zones. And the load, internal load, can be calculated using heart rate by summing the time spent in each different zone. So that's something that there are plenty of devices now who are doing that. There are several programs with this method and heart rate monitoring for load monitoring. The first element is, of course, they don't measure the psychological component. The second one is that rate fluctuates daily. Resting heart rate, that fluctuates by up to 6.5%. So in order to have those accurate zones, well, you need to calibrate the heart rate monitor fairly often, which can be a little bit cumbersome. Another problem is that if you use 2020 per age or kind of formula to predict maximum heart rate, because maximum heart rate also fluctuates over time, and you need to recalibrate. And sometimes systems are using equation or formula to estimate the maximum heart rate. Well, this doesn't work. It's not accurate. That's 2000 minus the age, and those are the actual data points. So you can see that's a trend, but the data points are showing totally different things. And finally, a more problematic issue, it's the heart rate VO2 is only visible and only works for efforts that are measuring, that are actually soliciting the aerobic activity. So this is the aerobic activity when VO2, the aerobic oxygen consumption, is meaningful, which is about the contribution of energy system here in about 6, 7, 10 minutes. And about 10 minutes, you get more than about 90% of the energy is provided by the oxygen in the body. So this is to say that everything that is below 3 minutes, so if you do a soccer, you're doing multiple sprints, volleyball, you don't do, except for a few aerobic workouts, you don't do much, basically never in that kind of zone here. So heart rate cannot be used to monitor that effectively. So heart rate monitoring is very effective, but only for aerobic activity. Now, the session RPE, that's the other tool that is widely used to monitor internal load. So the rationale is very simple. It's the difficulty of the session rated by the athlete multiplied by the rating here on a scale of 10, from rest to maximum. It combines a subjective and objective measures. So subjective is the rating and objective is the duration. It's now validated for more sports activity and also can be used for example, strength training. It's working for strength training. You can monitor strength training session with the session RPE and get the internal load, the response. And also age group. There are studies made with kids that shows that kids above 8 years old can self-rate their activity intensity fairly accurate. So also it's simple and it doesn't cost anything and you don't need any equipment. The main problem here is that you need to have athletes entering their data. You need to have athletes reporting, answering the question, how was your session? And then select kind of a number on the scale. So in some professional athletes, they don't like to do that. So a coach can do that for them. But for everybody below, all the athletes, even young ones, usually went after a little education and explanation why this is meaningful and useful. They will be able to. This graph here shows the relationship between, it's from a study from Impellizzeri that for 2004. The first scientists who compare the session RPE heart rate zone for soccer. So the black lines here are heart rate training load calculated by heart rate. And the line here at the top is the internal load calculated by the session RPE. So we can see that the curves are fairly the same. So the conclusion is from Impellizzeri is that session RPE is totally validated and totally useful to monitor internal load in soccer players. And this is this is 13 years old. Now, the key load management metrics. So there are plenty of metrics. Now, everyone has developed his own equation, his own indicator, his own metric. Well, but there are just a few of them who are really validated and are very studied by scientists. So in this presentation, I will not talk about homemade metrics or proprietary algorithm or things like that. I will just focus on those who have been published and widely used on the field. So the key metric number one is basically chronic load, acute load, freshness index. Chronic load, those three elements designed to anticipate fitness, fatigue, and freshness. Here you have a table that you can consider later on to get the equation about how to calculate load, weekly load, and monotony, and so on. So the chronic load is typically it's linked to fitness, so it's the work the athlete is preparing for. So it's the 4 to 6 week load, weekly load average. And on this graph, it's represented by the blue zone here. The acute load is the 3 to 7 day load, cumulative load. So this is linked to fatigue. And it's represented by the pink zone here. And the freshness index is the differential between the two. When you have workload, acute workload that is way over the chronic load, this means that the athlete is doing something that is not really prepared for. So you have the freshness index is going down. So you can expect high level of fatigue, change in mood state, and then if this tends down a little bit too much, then you can expect fatigue. You can expect injuries and problems. Key metric number 2, it's very important to increase load because high performance athletes need to be able to sustain very high loads for a long period of time to be as fit as possible. But so there is a way of achieving that, but it needs to be done very carefully. So one of the key principles is to increase load safely, progressively, and avoiding spiking loads. So going very, very smoothly. So you have tools to measure that and to control that. The acute chronic workload ratio. So that's the work from Tim Gabbett and colleagues, the first who bring this to light. And it's a very, very useful metric and very, very useful tool. So basically, it helps you keep the athletes in the high load, low risk zone, the one I showed you before on the graph. So here you have workload related likelihood to injuries, the sweet spot, and danger zone. And those are 0.8 to 1.3 roughly. So of course it will be depending on the athlete. It can fluctuate a little. Week to week load increase. When load is increasing too fast, let's say by 15% here, the risk of injury increased by 50%. That's another graph from Gabbett from last year. Here we have the graph. And here in real life, you have an increase in load. That's for professional rugby team. You have an increase in load by 20%, increase in load in 25%. So the risk will remain for a couple of days, but fortunately then the coach had decided to reduce the load just to mitigate the problem. Then you need to ensure adequate load distribution and training volume. Monotony, so that's the fluctuation of workload within the week. The strain of training is the load time monotony, so it's basically measuring the negative effect of heavy loads. That's the work from Foster, 1998, and then he did some study with elite speed skaters, and then he found that using the session RPE, he found that roughly 90% of illnesses were linked to peak in train within the 10 days before. Train, load, and monotony. So those are also very important elements. And especially for yours working with young athletes, there are studies from Gianti, very recent studies, that shows that when athletes are training more than 15 hours a week, those are for high school athletes, the risk can increase by more than 70%. So you need to keep the volume down. Or when athletes are training more week than their age, so you have a 10-year-old kid training more than 10 hours a week, where the risk increases. Finally, measuring the invisible. Self-reported wellness. Do you feel tired today? Do you feel sore? Are you tired? So those elements are very important. Personal feedback. Identify motivation, stress, fatigue. Enjoyment with training. Very important. It determines motivation and persistence. And lack of enjoyment is associated with sport dropouts and burnout. Here, there's a table why students quit a team sport. Well, almost 70% of them here, boys, are saying, well, either I wasn't not having fun, 40%, and 29% I got an injury. And the girl, 38%, I wasn't not having fun. So that's very, very huge. So those are particularly applicable to young athletes, but it's very, very important to make sure that they are having fun, even adults. And finally, wellness score should be used to guide the adaptation of training load. When self-reported wellness, morning wellness is not good, well, you need to make. Then you have additional metric, vertical jumps, heart rate variability. Vertical jump works well if you have the equipment and time. Heart rate variability, it's good, but it can be used, but it's very tricky to interpret. So it's not a kind of simple tool or simple metric to identify a recovery. You need to compare heart rate variability to other factors and individual history to make it work properly. So in practice, now I'll be just spending a few minutes showing you the load management. Well, with athlete monitoring, all athletes can report data using their smartphone. So I'm logged in here as an athlete on athlete monitoring. And then I have my awareness questionnaire. So then I can answer a question. Do you feel tired today? Do you feel sore today? How is your health? How many hours did you sleep? How was your sleep last night? So that's a sleep quality, very important. How is your mood? Very positive to terrible. Do you feel stressed? And then you can add, if you like, additional field to collect additional information. So it could be, let's say, heart rate variability, for example. And also, so athletes read the watch and then enter the number and maybe put some comments and save the form. When the form is saved, then the athlete can also report their own training session. So if you plan training session, they can click on the button, they select the activity, they select the difficulty or the RPE, if they enjoy it, maybe put some comments and save the session. Simple as that. They can also report pain, illnesses, and so on. Now, I'll be moving back to the coaching side and showing you how we work as a coach. So I'm logged in as a coach, and then athletes have been entering their data, and then I can open my team, and I see my dashboard. So the dashboard here, refresh the dashboard here. So on this dashboard, you have a holistic analysis of risk and readiness. So here you have the workload metric, acute chronic workload with alerts for this week and next week. Week to week load increase, when you load increasing too much, when you can see that and you can click on it, the system will suggest you some changes. You can edit you can open the program, edit the session, and modify it. So you can adapt training based on the alerts. You close the form, and then everything is adjusted. Monotony is analyzed as well. Enjoyment, you can get alerts. Wellness scores. So you see those wellness issue, when it's yellow or red, then of course it needs attention. So you can click on it, and then automatically you get the score for today. Fatigue, soreness, so you can identify what's going on. So from there, you can either contact the athlete and propose some alternative session, or you can just go into the program, modify the session, and then the athlete will receive the notification to the new session. You can also centralize feedback right there. Everything will be centralized. And if you want to have an overview of your entire team, you can open the team graph. And here you can compare what was planned by the coach, what was reported by the athlete for training load, for number of sessions, for duration, for RP, for pretty much everything. If you want to track enjoyment, compare enjoyment between athletes and so on, you can do that. If you have you use GPS heart rate, also you can create a custom field to collect and host this information. You can also see data over time. For wellness score, you can just click wellness, and then you get the wellness records or scores for each athlete and every day, and each color represents a wellness category. You can also, if you like, isolate if you just want to see who is really tired today, while you remove all the other metrics, and then you will see the fatigue score. And then if you want to have a better overview, that's a very useful graph, that if to get an overview about the different metric all together. So here we have our, each bar represents a day, each color represents a different activity. So in this, the daily load is 400, and then we have two different sessions. Then you have the acute load, chronic load, injuries in red, and that's a planned load. So even if you have planned data, then you can, your planned session, then you'll see the effect those sessions will have for the athlete. The risk factors, the acute chronic workload ratio. So you can see when it's at risk, when you know that between 0.8 and 1.3 is good. So it's about between this and there. So everything that is above or below then needs a lot of attention. So here in particular, you can see acute chronic workload is very high, chronic load is very high, and let's check monotony. Monotony is okay here, but here is not very good. So from here, you need to increase the contrast between sessions, between hard and easy and rest days during the week. So that will be an adjustment, a possible adjustment to decrease monotony and reduce the risk. And here, well, the acute chronic is very, very high, so it's going to be needed to decrease the load very importantly for at least a few days to allow the athlete to recover from that. So now I'm coming back to the presentation, and then I'll just finish a couple of conclusions. So in summary, load management, it's not that complicated. Actually, it's fairly simple. First of all, you need to plan workload carefully. So you make sure that you increase the weekly load very progressively. You avoid spikes or a very brutal increase. You avoid that. You alternate hard, moderate, and easy day. So you reduce the monotony. And then you make sure that athletes start taking at least one rest day a week. Then you adjust daily load based on athlete wellness. So you have athletes completing their wellness questionnaire in the morning, and you take those measurements into consideration to adapt the daily load. So you reduce external load during stressful period. When you know when athletes do have exams, when they are moving, when they are, for example, if you are working with athletes who are also teachers, in September when they are going back to school, it's terrible. And even young athletes, when they are going back to school, it's very stressful. So you need to reduce the external load. Everything needs to be considered. So you should reduce the total training volume for those athletes during a stressful period. And life event and sport-related stress. When perceived fatigue, quality of sleep, general health and well-being are down, where you need to adjust the load and to reduce it, and even talk with the athlete, discuss with them. And make sure that training is fun and enjoyable so you can keep athletes motivated and ready to perform well. Make it happen now. Those advices or recommendations, I would say, are just based on personal experience and some research, but mainly for personal experience. Every time we got success, it was on the same condition did apply to ensure the buy-in from the athletes and coach. This is essential. If you cannot have the coach understand the use of monitoring, well, the coach will not ask athlete to do it. And when head coaches not telling and requiring athletes to share the data, well, this is not going to work. The athletes will do that a little bit because they like you and you're nice. But if the head coach, who is the boss of the team, is not saying, well, those things are very important. I want every one of you to record it. And if you don't, well, it's going to be some consequences. Well, the athlete will stop doing it after a few. Another thing is that you need to trust athletes and talk with them. Athletes will trust you if you trust them. If you don't trust them and then you tell, well, I don't trust them, so I just plug them a GPS and then we'll work from there. With only GPS measurement, you can get away with some good results as well, but you will miss all the psychological component that is crucial in my opinion. And also you will only be able to monitor activity that can be measured with GPS. Then you need to monitor the key metrics and use them to adapt the program. So you measure wellness, session RPE, acute chronic workload, all those metrics that I presented earlier. And finally, you keep it simple. That's number one key as well. Well, number three. You only collect data that really matters. Now with technology, you can collect tons and thousands of data. But in fact, you have maybe to monitor load properly and effectively, you maybe need maximum 10 variables. So make sure that you select the right metric and you focus on that and it will work. Yeah, of course, you should use a specialized software. There are plenty of on the market. Some are complete, so very sophisticated. Some are extremely expensive. Some others are very simplistic. Some are between. And of course, you can try our athlete monitoring and request file or take a look at the website because people seems to like it. GPS data, Excel, of course, is good, but it's very, very time consuming. So, if you want to work professionally and make your time worthwhile, well, just make sure that you invest in a good software. GPS, power meters, heart rate monitors, they are a plus, but they are not absolutely mandatory. You can go without. Those are a few success stories from some of our users and clients. Thank you very much. I hope that you enjoyed the presentation. You have my contact in this section here. If you want to email me or to get in touch, feel free to do it. If you want to have a look at athlete monitoring, try it. You can go to the website athletemonitoring.com. You have a look at the system. And now, if you like, we can have a few minutes for a few questions, and I'll be happy to answer.